Good afternoon, everyone. Today, I will be presenting my topic Retrieval Augmented Generation or RAG, which focuses on building more reliable AI systems. This topic is part of my coursework on latest advances in engineering and technology, and also I will just briefly discuss its practical implementation. Large language models are very powerful, but they have a major limitation. They rely only on their training data. Because of this, they sometimes generate incorrect answers, which is also known as hallucination. They can also provide outdated information and cannot access domain specific knowledge or private data. These limitations reduce their reliability in real world applications. To solve these problems, we use retrieval augmented generation. RAG combines two things: information retrieval and text generation. Instead of relying only on internal knowledge, the system first retrieves relevant information from external sources and then generates the answer. So the model does not guess, it uses actual data. Let's understand how RAG works step by step. First, the user asks a question, which the query is then converted into embeddings, which represent the meaning of the text. These embeddings are used to search a vector database. The system retrieves the most relevant documents. Finally, the large language model generates the answers using the retrieved context. This diagram shows the complete architecture of a RAG system. On the left, we have the user query. It is converted into embeddings using an embedding model. Then the vector database stores document embeddings and allows similarity search. The retriever selects the most relevant information. Finally, the large language model uses the context to generate the final response. This flow ensures that the answer is based on the real data rather than assumptions. Let us consider a practical example. Suppose a user uploads a document like a notes or a research paper. When the user asks a question, the system does not generate answer randomly. Instead, it retrieves the relevant sections from the document and uses them to generate the response. This significantly improves accuracy and makes the system more reliable. Now let's compare RAG with fine tuning. Fine tuning involves retaining the model with new data, which is expensive and difficult to update frequently. RAG, on the other hand, allows us to update knowledge simply by updating the data source. So RAG is more flexible and cost effective. However, it introduces additional complexity in system design. Although RAG improves reliability, it has some challenges. Its performance depends on retrieval quality. If the system retrieves incorrect data, the output will be incorrect. So it also introduces latency due to retrieval step and requires very structured data. From my understanding and implementation, I realized that the quality of retrieval is more important than the model itself. Even a powerful model cannot give good results if the retrieved data is not relevant. This shows that building AI systems is not just about choosing the model, but about designing an entire pipeline carefully. To conclude, retrieval augmented generation is a powerful approach for improving the reliability of AI systems. It combines retrieval with generation to produce accurate and context-aware responses. This makes it highly suitable for real-world applications where correctness is important. Thank you.